Okay, so today we're going to go ahead and work on percentile ranking and see how it's happening through Reddit data. Where does it come from? Where does it originate from, first of all, and especially the interpretation that has been used and the process. And then pretty much how we can get from raw data, how we can get from a data table that pretty much is ungrouped data, which we could for test classes. Or from qualitative data, these percentiles only come from qualitative, doesn't come from categorical. Keep that in mind. You have to percentile measure score. And from a table that has group data or histogram that has group data. So the question is, how does it adjust? When does that the formula comes introduced? Some people may use the boundary point to do the formula in regards to grouped data, but sometimes they don't realize that ungrouped data, you really are starting at the scores and get our scores below. So we should be really looking at the group data and using that for the row limit, which is the lower limit, not boundary points. So that's what I do. I just do for the true row limits. I don't look for any type of boundary point when I do it. But I'll show you how they both will work either way. So we can go ahead and see how it's done. But let's go ahead and look and see, okay, what percentile ranking is. Okay, what's a percentile? I do a part for a screen that brightness will be right here. If I need to, if I remember, it's in the sheet right here, to write above it so you can see what's there. Anyways, the percentile of the score measurement represents the percentage of scores or measurements that are below that specific score or measurement. I don't have A there, but you could think that as that specific score or measurement. Okay. So we really pretty much say that this measurement is the K percentile of the data. It's also denoted as PK, piece of K. That's pretty much what's happening within there. Okay. So let's just go and say, okay, what does that really mean? So we have termed that. What does that mean? It's very commonly used in schools. I just didn't realize what I understood. I didn't take statistics when I was in high school. Sadly, I took calculus. I enjoyed my math field. But stats would have been great if I were to take the advantage of taking it during high school. But there was a time where I read on the hallway that our school was pretty much in a certain percentile. I can't remember what it was. But I remember that, and I thought, okay, well, does that mean that we all have a percentage of our students are pertaining scoring at that rate? And our percentage was pretty high. So now, cool, a lot of us are successful. But then I realized I was wrong. I had the wrong interpretation because I didn't take statistics back in the day. It turns out that the percentile was pretty much saying that a certain percentage of other schools that were in our district was scoring below us. Okay. In comparison of all schools in our particular district. That's what it really was saying. And that's what this come over here with the whole is percentage of scores or measurements that are below specifically. Okay? It has nothing to do with my personal score or the school's personal score. It's comparing our school with every other school in our district and getting the average data. That's what it was doing. So here's a diagram, and I'm pretty sure right here you might be missing what's right here. But already saying right here, this is the permanent line that goes for our X value, which is our K percentile. So I'll write here X where it's piece of K, and we should note that piece of K is also another way of saying the K percentile. And this is probably like a range of values that pretty much what we know is that we have the smallest value in our data set. Okay? And the largest value in our data set. So, parameters we're saying over here, and these are our scores or measures, whatever we're looking at in terms of our variables. And we're talking about the K percentile, we're saying that clearly below them, the bottom, this K percentile separates the bottom K percent from the top 1 minus K percent. So what we're saying over here was 80%, that's 88, 80% below, that means that 23% of the data has to be above, on top of it. So that's what we kind of get at here, and the other example does show that, and how do we actually interpret it. So I'll move to the next example, and we'll see that clearly if I have it written up. But let me erase what's right here first before moving. Okay, so over here, if a student is in the 35th percentile of a geometry or a geography test with a score of 78, how do we interpret this? Well, we interpret it by saying, well, then 35% of the other students scored below that 78%. That's the score of a particular student that we looked at. Okay? Well, at the same time, 65% of the other students scored either the same as or above. Okay? The same as, it's kind of loosely depending on how and what direction you're doing the percentile. If you start from data, it's definitely same or above. If you're getting from percentile and you're trying to go within the data, it kind of does vary. But we're going to hold here, we're finding percentile from data. That's what we're doing. Okay. So that's where it's coming from. And we clear over here. Well, we see over here the score of 78 has percentile of 35%. So we're clearly saying that over here, the bottom 35, and over here the top 65. And he's just a divider. We're inserting this here sheet. It's just a divider. So that's what that's getting at. So let's see this in action. First, we're going to get the actual data, then we're going to turn that data into a distribution table or a frequency graph for the most part. So we're going over here and say, okay, how do you find the percentile from a data set or given list of data? To find the percentile ranking of a score or measurement from a given data set, use the following process. What we're saying here is, first is very important that we sort. We need to sort. Okay. So we're going to sort the data from, we're going to arrange the scores and measurements in the data set in ascending order. Okay. If necessary, do it in ascending order? Great. If it's not in ascending order, we have to rearrange it. And there should be a way in the calculator to do so. I had to look into it again. I was busy working with graph trackers and I found those guys out. But I'll look at it again. So over here, find the frequency score or measurement that we're looking at here. Okay, and what we're saying over here is we want to find out how many of them are less, not equal to or greater than. Only specific those are less. Because on percentile, it's separating the bottom from the top, and the top can have the same or equal or greater than. So we have to make sure we get those are below. Once we have the frequency for those who are below, we're going to pretty much divide calculate the corresponding percentage of the frequency found in this in step 2. And we're always going to round to 100%. And we should already know how to find permanent percent. Percent is permanent found by getting the frequency divided by the number of participants and multiplying it by 100%. So we get the proportion and multiply by 100%. So hopefully we know that, and we call that from past practices. So we'll go to the next page and we'll see it happen. So here's an example. Notice how our data is in ascending order. So it made it in ascending order for us. That's great. So I found it sorted. When I say sorted, permanently in ascending or descending order. So we have it sorted in ascending order. So we don't have to worry about rearranging it. So we're good with that. But that will be the first step of when we're doing it by data. So over here, we want to find and interpret the percentile rank of a patient in with the indicated depression score using the data set below. Well, here's the data set, and we're going to be working it out. So what we're saying here is for the depression score of 18, and then we do for the depression score of 20. Well, I'll pretty much do the work over here on the side. I do have space to show the calculator usages for each one, which I'll pretty much be doing with this guy right here for right now. Hope you can see it, a little too dark. So I'll bring it over here, where it's a little more brighter. Might need to adjust because of the lighting and settings. It's not that good in here. Let me just look real quick, see if it works. Not working. Readjust it, button readjust from what I had before. Okay. Anyways, let me make it so the screen can be shown. So over here you might not be able to see much because of the light, but I'll probably be writing over here to let you know what it is. But anyways, let's get to the first one. Let's answer the first question. And I'll probably put that one in green. So what we get over here is the bottom 18. So want this one final percentile rate that corresponds to 18. So our job is to find wherever the PK is, find the K, that's going to equal 18. So how do we find that K? Well, the K is supposed to be the percentage. So we're looking for all the frequencies, okay, that are below 18. And we divide it by the number of participants, and we times that by 100. That's all we're really doing here in reality. That's all we're really doing. So I'm going to find how many is below 18. Well, 18 is right here, and that's the lowest one, okay? I don't want the same, I just want the one below. So I'm going to circle the first 18 that's there, and I'm going to find out how many are below. So when we look over here, we notice that there is 1, 2, 3 below. So therefore, over here, we say, okay, well, I'm looking at 3 below. How many are in total? Well, there's actually 24. So we're seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're looking at pretty much 12 times 2, which is 24. And that's our n. So we're probably looking at 3 over 24 times 100%. That's what we're looking at here. So let's go put that to our calculator and see what we get. So how do we do this? Well, right here is our fraction. I know you can't see it, but it is our fraction. And we're just seeing it as being n over d. So this right here is supposed to be giving us the fraction setup in this calculator. So therefore, I'm going to clear this real quick. I was trying it earlier, see if we can see things. But I'm going to hit the button to get the fraction. And then I'm going to go ahead and put 3 in the numerator. 100, I'm sorry, not 100, 24 in the denominator. Let me see that real quick. 24. And then I'm going to times it by 100. That's all I'm going to do. Okay. We ended with a fraction, 25 over 2. So, but that's not helpful because I want to have it rounded into decimals. So I'm going to go ahead and click on this converting button right here. That's converting. And when I click the convert button, we definitely see that it gives us a decimal. So when you hit the converting button, it goes from fraction to decimal. Okay. F, 2, D. Okay. Fraction to decimal. Good lowercase. Continue lowercase. Okay, so there we go. So now our jobs are on to 100%. So all we know over here is it's supposed to be 12.5%, but we don't want that. We don't want it in that format. So we're going to approximate it and get us 13. Okay. So that's what we're seeing there. So I know at this time, the conclusion that we have for the green is we know that 18 is P sub 13, or we could say 13th percentile. Okay. So we'll be saying that. That's what 18 is, then we write 18 a little nicer. It's a little messy. Okay. But 18 is either P sub 13 or the 13th percentile. So let's go finish it over. Probably I'll do it all in orange. I'm gonna give it this real quick. Can I need the space that's over here? If you note that guy down. So now I'm gonna go for the differential score of 20 and see how that one's working. Well, once again before, we're saying that it's one that's below, not the one that's same or greater than. So I go for the first 20, and the first 20 is right here. And now I'm going to find all those that are below. Well, we clearly notice that from here and all these guys are below the 16. I mean 20. And there's roughly 12 above and plus 4 more. So we're looking at a total of 16. So what we're seeing over here is we want to find the same thing. We're looking at, okay, what piece of k value is going to equal 20? So we represent 20. And we're going to look over here at the kth value. It's going to equal, once again, the percentage below, which is going to be 16 over 24 times 100%. So all I gotta do is put this into our calculator and do the same thing. So I'm gonna do the same thing, so I'm gonna put, oh, wrong one. Quit. Supposed to be 16 divided by 24. And on the outside, I'm gonna put times 100. And enter. Oh, do the same thing. So once again, all we need to do is convert. Once again, I told you it's over here. If you have the other calculator, I'll pretty much be showing you how that's working. So over here, what we're just pretty much saying here is, if it was exact, we're pretty much looking at 66.66666, pretty much running on. So literally, it is more like saying 6 bar. But we don't want the exact answer, we want the approximate one. So what I'm gonna do here is I'm gonna round to the nearest whole number, which says that, oh, this is greater than 5. So we're definitely seeing it, is it greater than equal to 5? And that is being checked off, so that means the 6 has to be rounded up to a 7. Giving us approximately, approximately 67. So the k value is 67. So all we have to do here, what we're definitely seeing here is that 20, the score of 20 is in the 67th percentile, you could write. Or you could simply say right here is P 67. What do you get that for? 67. And appropriately saying 20 is P 67, we're saying that 20 is in the 60th percentile, or is the 60th percentile. And that's pretty much how that's working here for this calculator. So notice how we're just getting that below. Just real quick for the calculators, if you pretty much don't have those, like over here, some people may not even have the potential of getting a fraction based off the calculator they have. So we have to be alert of that. And over here, the fraction that's here won't work. It's just right here somewhere. I can't see it right away. But I never really use it because of it. So what we're going to do over here is we have to do the long way. So it's very important, what we see here is that operation is important, so you see parentheses like this, parentheses like these, because it's going to be a decimal plus or minus, it'll be great to put in parentheses to play it safe. That's the most important thing, you want to play it safe. So over here, I'm going to turn it on first, clear it, and then we'll put parentheses to ensure that the fraction will be in there. Now I'm going to write the fraction, so it's going to be 16 divided by 24. And then outside of the parentheses, I closed it, that's one fraction thing, and then I'm going to times it by 100. And that's just to keep it safe, because that could be an addition, and then if you don't put parentheses, it is short. So that's always do other operations, multiplication or not. So enter that, notice I get the same thing. So I could go ahead and convert it over. Okay. For those of you guys who may have the seal, something happens, and I could be showing that too, right here. So over here, we see the fraction bar right here, because I was moving. A fraction over here, so we hit the fraction bar. At first, we can turn it on. Keep getting turned on. Oh, that's right. The other one, that's right there. On, and there's switching in the calculate one, so make sure if you need to go to menu and be on a calculation or comp for computing. So I'm gonna press 1 or enter after it's highlighted. Now I'm there. Now I'm gonna press the fraction buttons right here. Get the fraction, and now I could literally write the 16 again. in the numerator. In the denominator, I'm gonna put 24. And outside, see the big dash, that tells me I'm outside, I'm gonna put times 100. And I'm mimicking it again, now enter. And once again, there's a fraction like it did before, and what I gotta do is convert it appropriately. So once again, what's converted? It's supposed to be the button that's right next to it. Let me see if that is, well, I'm sorry, that's for another class, another one. Our conversion is right here. SD. This is the same thing as saying fraction to decimals, but this is actually saying any type of syntax, okay, or script into decimals. That's all that's saying. So when I press it, it goes into decimals. And we're seeing the same results for each one. So know what you have and be able to deal with it. I can't really go beyond that. It all depends on the type of card you have. You all have their own limitations. So we get that way. So we're good with those. That's how we can do it for regular data percentile rankings. But now let's go ahead and move on to the next one, which is pretty much the tables, the frequency distribution tables that may be grouped or may be ungrouped, non-grouped. Or one I usually call a class, or the other I call intervals. Okay, they're still both still classes. So let's get to the next one. Here we go. Well, here's the work. I just did over here for us, but the work is pretty much done here. Do you want to get the slide? You didn't have to do so. I already did the work. Naturally. You guys see how it's working. And okay, good. So here's the interpretation I forgot to do. So when we got that once we found out that what was the number? Okay, it's going to be here somewhere. 18 was the 30th percentile. All we're saying here as interpretation that 30% of the participants have a depression score less than 18. Okay. While the other 87% have a depression score that is the same or is greater than 18. You know, this right here is kind of loosely from going the other way around, but it's what it means. How we found it, that's the question. How we found it is key. And then over here, when you get to the interpretation for 21, we found out it was in the 83rd percentile. Wait, where is it different? I could refer, 21. I did 20 last time. Is that a good typo? Yeah, it was a typo. Right here, if it's 21, over here I had 20. So when I did the work, I actually put it over here wrong. Okay. So I ain't gonna worry about this one. It's the one that was over here. So if we replace it, we're saying that 20 is the 67th percentile. So 67 of them, if we were to, I'm just going to change over here in blue. So what we're saying here is instead of putting this, we're putting 67%. And over here was 67. So 67% of all the patients have a depression score below 20, while over here would actually been 13% have a depression score either the same or above 20. And I was supposed to have to work to get it over there. I'm shocked I didn't notice that. But that's pretty much what's happening there. Because the work I have right here for the 20. So now let's go and push forward. So what if I got that data and I put it into a histogram? Okay. Into a histogram or a distribution table that pretty much has ungrouped data. So notice why is it ungrouped? It's because you don't see any interval here. Because you don't see an interval here, it's ungrouped. This is the data by itself. And the beautiful thing about ungrouped data is it gets you back to the original. It really does. So over here, 15, well, instead of 115, nice. There were 0 16s because none of them exist in here. 2 17s because there's 2 17 here. 5 find 18 because there's 1, 2, 3, 4, 5, 18. So ungrouped data is giving us back the original data set. So that means that in reality, I could actually treat this guy like I did here, and not have to worry about a unique formula because it's ungrouped. When it's not ungrouped, when it is grouped, then we have to worry about certain situations, and we'll see that. So we can find it the exact same way when we're doing the work. So first what I'm gonna do here is I'm gonna show you the example of doing it to find 18 again. I believe it was that one or my version one. This is something that was mentioned before, so we wanna spend time pausing it and looking at it. It's probably saying the same thing. Gives back the original data, therefore I can calculate the same way I did like regular data. That's all it's saying. What we said. Okay. So here's our example. Okay. Oh, and we're going for 21. So we're going for the other one that accidentally did 24. Okay. But we're gonna get the same result as what the slide previously had. So come over here. Once again, these are ungrouped data, so we know these guys are giving back or representing the actual data itself, so we don't have nothing to worry about. So what I'm gonna do here is, let's go and find 21. I'm gonna put wrong. So 21. Well, we know 21 is right here. So we know that it's ungrouped, so we know that all the values over here are gonna be the individual values that is represented in the data. Same thing pretty much happening over here at 21. We've seen it right here. Here's your 21. That's our score and focus, or in this case, is a score, but also a measurement score. Okay. So come over here. We notice that we are looking here and below. Okay. That's what we're doing. So let's find out what the frequencies are so we can go ahead and get them situated. Well, where we said over here that 15 is supposed to have 1, over here was 0, over here was 2, then it was 5, 8, 4, 3, and 1. And we can also find it by looking at the hinges right here. We know that if the scale is based off 2, we have 2 scales up to 8, so the happy marker has to be 1. And that's what we're getting here. And similar everywhere else. Happy marker has been 3, 5, 7 top, 5, and 7. So we could find the scaling, especially if it's even jumps. If it's 3s, you have to split it into 2s to get the even spacing. But that's pretty much it. So now, how do we get the answer to this? Well, we're doing the same thing. I want to find out how on the frequency of those below 21. So I'm trying to find the pK that corresponds with 21. The kth value, or the kth percent, is found by finding all those below, frequencies of those below 21. And then we divide it by n, and then times by 100. So we're going to do the same idea. So come over here. Well, let's do the work for us. It's only 4, so we're seeing it in this value 4 now. So if I add up all these guys right here, and these are frequencies for 21 and below, I'm going to say 20 and below, we add them all up going down. It turns out we're going to have pretty much 10, 19, 20. 20 more. So therefore we're looking at 20, and if we get the over n, if this n's not here, all you need to do is add it all down, and it should be 24 as well. Just add up all the frequencies, and we get 24, and pretty much times by 100. Same thing's found on the graph. I could do the same thing here. I would have added all these guys up, because those are all below the 21, because 21 is the next number down, or 20 is the next number down, because it's pretty much non-group data, and we'll get the same thing done. So putting this into a calculator, we should end up getting the same results. So I'll get the friend to cast over right now, because the one on top, and we get the same result doing so. So I'll put the fraction, and then I'll put 20 divided by 24, times 100, and then I'm going to convert. And we end up with the same result as what was previously on the previous slide with 421. So we're pretty much looking at, come over here, and I'm looking at it being 83.333 and on. So I'm looking at approximately 83, and that is your K percentile. So what we're saying here is that 21 is P sub 83. Or you could simply write the 83 percentile, the 83rd percentile. Yeah. And we have our terms of inclusion, and we could interpret it as such. Remember, percentile only represents the percentage of those scores below a 21. Okay, nothing else. And now we could figure out how many percentage is either the same or above 21. So notice pretty much we're seeing the same thing, same idea. However, you could also use the formula for this one here, which what others might be showing. At the examples towards the end, once I show you how to actually do a group data and how to use global limits, and then we could go from there. So I'm going to erase this, we get to the next slide, and enjoy the rest of the problem, or problem sets. Okay. Oh, and there's the word. Haha, how funny. What's on the next slide? I did promise to work for us. But same thing's happening. Because once again, you're promised doing the work, and that's what I just did. Okay. So group data. Now we're looking at intervals. Notice how we have intervals now. So, like I showed you guys before, so over here for the lower, because ours is building up. So for the number between 10 and 19, wherever 19 is not the real limit, it's just a limit. It's just that's not the real upper limit. 21, 20 is. So we're really looking between here. So the value that's in this guy, it belongs in this value because this 20 is where this and it was supposed to be starting. So what we're looking at here, so we don't really know we don't really have the real limits, and therefore this is kind of is really based off of limits. So we keep that in mind. Limits is the key. So come over here, but the key thing I was going to show you is here. We're saying that we know the only thing we know is that 3 of the scores is within this range of values. That's all we know. We have nothing that talks about the exact data. We don't know where it came from or produced, even though it's up here. If this was out here and we just had this table, we have no idea what the scores were. We have no idea. So we can't assume that we know. That's how here because that's what data is. We can see how the process to finding certain scores is going to differ. Okay. So over here we can just use it. Over here we cannot use the regular approach because we don't know how many values are as such. Over here is just assumptions. But that's all we have here. That's what we're looking at. So now that we have that out of the way, if you take the next slide, we're going to say the same thing on the next slide. You just be reading what I said, and it's all here. Okay? Everything I just told you right now, it's all there. You can pause it and go ahead and copy it down or note it down, but I've already mentioned everything. So what is the process? What's the new process? What is, because I don't know how many value, I don't know what the value is that where if it even does exist, and I have no exactly how many of them are below or how many times it repeats itself. So there's no way I could be able to find out how many exactly is below. Because there's no way. It's impossible. So we have something called the formula. This formula defines any type of percentile ranking, okay, for any type of table or frequency table or histogram, frequency histogram. So, a percentile score is calculated using the formula that's given below. And what we're seeing here is the percentile, remember this is your K right here, here's your K percentile that we're looking for. It depends on us knowing the cumulative frequencies that we learned earlier of the below this particular interval. So once we know our interval, we go for those below it. In terms of values, we're not talking about location, we're talking about value here. We need to know the score we're focusing on and the real lower limit. Okay, remember, once again, we need to know real limits. That's why I'm mentioning real limits. And then we're talking about we have to know the interval size. And now we can find out by looking at the real limits as well. Knowing the real limits, once again, is key. And then we also need to know the frequency within the interval. That plays a detrimental factor because we know guesstimate how many percentages if it really did exist. N, which is the number of participants, and then we already know that always times 100%. And that's what we're saying here. So in text, I'm just saying real limit, which is the lower limit, okay, of the interval, and then below intervals is those the same values right below. And always round percentile centers percentage. So same thing's happening consistently. Okay, so here we go. So our job, our task, is to pretty much find and interpret the percentile rank for the driving time of 43 minutes. So we're going to see the next slide what's happening here and kind of have it set up for us to actually enjoy and figure things out. So here it is, our solution. Let's build the solution. I already have things kind of highlighted for us. Did an example, and when we highlight it, we're going to be figuring that out ourselves. But since 43 falls in the class containing 49, 40 through 49, and it's pretty clear because we're in this region right here, 43 is that clearly in here. Okay, it's greater than the lower limit and it's definitely smaller than the real limit of 50. So therefore, that's our interval of focus. That's what we're focused on. That's our interval. That's why over here our permanents have in purple. I should have used my purple marker that's over there. It's supposed to be 3. So once again, knowing your real limit. So when we convert, make sure that we know this interval is from 40 to 50. So that can help us find the interval size. And that's what permanents did over here. In this region right here, I got the difference of the real limits, and that ended up giving us 10. So we have that in there. Well, we already know the lower limit is the lower limit of the interval that we're focused on. So therefore, it's going to be the 40, that's right here. That's what comes over here for the lower limit. So let's look at the frequency, because that's what comes over here. The frequency. Well, the frequency and the interval of focus. So now that we know our interval of focus, we know our frequency that we're going to be using. So it's going to be 4. That's what we're going to be using. Next, well, we have to get the sum, get the n, which is what is the mobile frequencies. But once again, this n most likely will not be there. And that's something you have to find. You have to find this n. And all we're doing is adding up all these frequencies. That's all we're doing. We're adding up all the frequencies, and that's how we get n. And one thing we're missing now is the cumulative frequency below. So notice how we here 16 is the one we highlighted, but once again, sometimes cumulative frequency is not provided, and your job is to find cumulative frequency for that particular class. You don't have to really try to find all of them. If you want, that's sort of your choice. But usually this will not be provided. I provided here for this example and for the other ones. Okay. Maybe I should have widened it out for another one, but it's there. So I'm gonna try to maybe just group it out so we can catch on to it, how it works. But anyways, we pretty much look at the scores below, and we're looking here. So this is where the cumulative frequency is coming from, the scores below. And therefore, 5 plus 8 plus 3 is going to give us 16. And that's what we have over here. Okay? So, now all we really need to do is put this into the formula, so we're just replacing values. And I've done so on another slide, so we can see it happen. What we're saying is, for instance, 43 is going to go right here. It's 40, it's going to go right here. I guess I'll just write it. Where's that purple at? So what we're saying is, this is a 43. It's black. That's not purple. 42 goes right here. My green is supposed to be the 40. So the 40 will go right here in that region. Okay. Right below where we have our interval size, and I put it in orange. This guy here is supposed to be the interval size of 10. That's what's going to take it in that place. Well, right below that we have our n, and we know that is supposed to be our 24. The 24 is taken up that place. We found that the cumulative frequency was supposed to be 16, so 16 will be going right here. That is orange, supposed to be red. And our frequency that corresponded with the interval was supposed to be 4. So all that goes inside the parentheses with those values, and no one is obviously outside. And we'll see that in the next slide, because it's a little messy over here, but that's what really happened. Okay. So then we'll go ahead and flip it over and erase what's up here. And we'll see that here. Right here. What I just replaced is right here. Okay, so depending on the teacher and whatnot, they might say, well, I want you to show how you work, show me how to do order of operations, and spend the next, I guess, 5 minutes or so trying to simplify this whole thing fully. But at the end of the day, and with decimals, which is pretty sad, okay, and dealing with decimals by hand methods. It might be as accurate as possible. So the best thing to use is calculator technology. And we can actually build this in calculator. It looks kind of crazy. It looks kind of like, what the hell, how am I supposed to do this? But we can definitely build this by using fractions. And if you don't have fractions, it's okay. I'm going to find a way to show you the long one. I'm going to have to do it up here on top when I'm done. I'll write the long one for those who don't have fractions. And we'll see how the long one is, how the long one incorporate with that one. Okay? But let me just go ahead and put the calculator uses in here, and we can get that done right away. So on. So once again, I have parentheses, right? So the first thing I'm going to do, I'm going to input the parentheses. That's the first and close one. Now I'm going to start the fraction. So we have a numerator and denominator. So I'm going to first put the fraction. So we already know the denominator, or the denominator has is 24. So I can put 24 here, and then the numerator I have to input this guy. So I'm going to do the 24 first in the denominator, since it's the easy one to do. I'm going to go down to 24, and then I'm going to go back up. So now I'm going to put that the next expression into the calculator. The 16 plus the fraction of 43 minus 40 divided by 10 multiplied by 4 in. When you see this multiplication, double multiplication right here, you could choose to put the 4 on right the same way, or this is right here the same thing as saying times 4. Double multiplication is the parentheses product, the dot product, or the cross product. Okay, so when your choice of how you want to interpret it. But anyways, in the numerator we have 16, there it is, plus the parentheses, and now I'm make the next fraction by just pressing fraction bar again, see how it builds it, right into it, and now we put the 43 minus the 40, divide that by 10, go outside, now notice I'm outside that the top fraction with the cursor there indicating it, put the parentheses. So see how it's only closing parentheses in the first fraction. Good. So now I'm going to finish off the expression by putting in the 4, the times 4. So I'm going to put times 4. Oh, that's divided by smart guy. Times, which is right next to it, 4. Okay, we have the multiplication there. So now I'm done with this fraction here. So I'm going to jump outside the fraction by pressing right. So notice I went to the denominator. That's okay. Keep going until you see the big slash that says, oh, here's my indentation, you are now outside. So now I can put the next parentheses right there. So now notice that the whole first parentheses is done. So what I need to do now is multiply by the 100. So times 100. Oop, times 100. So now we see a whole expression there. And you see that arrow that's right here? This arrow that's right here. Remember, I was saying there's more to the side over here. So you want to see those guys, are you ready to just press the arrow to the right? And they'll show. But notice over here you can't see the whole thing, which is pretty sad, because it does big text, which is one thing I like about it. But it didn't show everything. And therefore, everything's good. I double checked it, everything is good. So now I'm just press enter. And dang, I get fraction again, but that's okay. All I gotta do is convert it right here with the converter. And we end up with 77.66, which is pretty much the same thing happened right here. So when I approximate it, round to the nearest percentage, I'm saying that the 47 minutes is in the 72nd percentile, aka 43 is P sub 72. So the other calculator, same thing. So what's the same function now for any calculator that has the fraction? So what I'm saying is we're doing the same thing for this guy, the TI-30XS. However, if you're going to be using, if you have this one on you, which I hope that's not the case, but if you do, or a TI-4 that cannot make fractions, it's okay. We can go the long way, and I'll show you how that's working here. First thing first, I'm gonna write the long way, because apparently we don't know the long way. And you're gonna see how interesting it is. Because grouping is important, grouping symbol is important. So, first thing first, well, I have this parenthesis here that has to be separated. So I'm gonna first put a parenthesis to indicate this. I'm gonna change the color. I guess I'll do green. So this one here is pretty much indicating this first parenthesis right here. But we have to watch out for something very, 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 very important. We should understand that this is a numerator that, crap. Woo! Okay. This is a numerator that has operations that, so in operation, when I'm saying operations, I don't really care if it's multiplication, addition, subtraction, I treat it all the same, because it's an operation.